Assalamualaikum and a very good morning. I bid to Dr. Amrallah bin Mustafa. So I am Shahriz bin Suhaimi together with Syed Muhammad Safwan and Amir Faris. We are going to present to you about our mini project which is DC analog voltmeter. So before we go through the DC analog voltmeter, let me show you the project background of our mini project. So the DC voltmeter is a measuring instrument which is used to measure a DC voltage across any 2 points of a circuit. A permanent magnet moving coil PMMC, which comprises of a deflection meter and a meter resistance, will make a DC voltmeter if a multiplier resistance is connected in series with it. The multiplier resistance will ensure that the amount of current that is passing through the PMMC will only reach the peak value corresponding to the full-scale deflection, FSD. The value of FSD will deflect the meter at full or maximum scale depending on the type of the voltmeter itself. So basically from what we can see right now, we have the PMMC instrument here which consists of the meter as well as the meter resistance. And together connected in series with it, we have the multiplier resistance to make a properly functional DC voltmeter. And now to the objectives of our mini project. So we want to design a DC analog voltmeter aiming to measure the value of the input voltages. We want to also demonstrate the design and simulation of a DC analog voltmeter using IC's Proteus schematic design software. And to prove the manual calculation of the voltmeter reading through the result of simulation. In this case, we will also calculate manually using calculation, and we will compare the result of the calculation together with the result of the simulation. And now, moving on to the problem statements, we have outlined about 3 problem statements that need to be addressed in this mini project. So for the first problem statement is that how to design an effective DC analog voltmeter that can measure the accurate value of a DC voltage. The second one is how to simulate a virtual DC analog voltmeter which can function the same way as the physical voltmeter. And the third one is how to ensure the reading of the DC analog voltmeter to be corresponding with the calculated ones. So moving on to the methodology on how do we want to address the problem statements. So for the first step, we will identify the components first. So the components that will make up the DC analog voltmeter are resistors, switches, PMMC meter, as well as a voltage source. And the second step is to design the schematic diagram. After we have identified all of the components needed in order to build this DC analog voltmeter, the schematic design of a DC analog voltmeter is then designed using the IC's Proteus schematic design software. The components are properly placed into their respective position according to the real configuration. We need to ensure that the positions are well placed. The position of the components are well placed in order to ensure that the output of the DC analog voltmeter to be precise and to avoid any error. The third step is to simulate the design. The completed design is then simulated to obtain the value of a DC voltage that is measured on a load. And the last step is to compare the output. A manual calculation of the DC voltage is also performed, and the results of the simulation and the calculation are compared. So basically, we will ensure that the result of the calculation to be tally with the result of the simulation. And this is important to ensure that it is to prove the design and the simulation of our system is free from error, and also the calculation of our output are correct. So we have 4 expected outcomes that we will expect. So the schematic diagram of a DC analog voltmeter can be designed and is able to measure the value of the DC voltage on any given 2 points. Basically, what it wants to say that it can measure the voltage drop between 2 points without any errors. And the simulation of the DC analog voltmeter will show the function of this virtual voltmeter to be corresponding just like the physical one. So this second outcome is very important because we want to prove to you that our simulation, our constructed DC analog voltmeter, the virtual one, will give the same output just like the physical one. And the third outcome is the output voltages as shown from this DC analog voltmeter will be similar like the calculated ones. So if we can prove to you that the calculation value as well as the simulation value are the same, basically our simulation are correct as well as the calculation also is correct. So which means that the simulation is free from any error and the design is approved. And the last outcome is students will be able to learn on how to plan and to design an effective DC analog voltmeter that can yield a very accurate reading. So basically, because we have to design a virtual one without having to design the physical one. So basically, it is really important for the students to plan the proper design of a DC analog voltmeter so that the output of the voltmeter will just be the same or corresponds to the real one.
Thank you, Shahrish, for the introduction. So now, I am going to show the simulation for this project. But before that, this is the schematic diagram for the DC analog voltmeter. And for this case, this is a multi-range DC analog voltmeter. The DC analog voltmeter multi-range was made up from a multiple switch and several multiplier resistors. The 5-position switch will max contact with only one resistor at a time, and each resistor is sized to provide a particular full-scale range for the voltmeter. So, for a voltmeter with ranges of 1 volt, the resistance for multiplier is 500 ohm, and for 10 volt it will need 9 kilo ohms. For 100 volts it will need 90k ohms, and for 1000 volts it will need 100k ohms. And the voltmeter was in a full scale 1 milliampere and 500 resistors. So now I will show the simulation using the Proteus program. For a 1 volt, it will require 500 ohms of multiplier resistor. So if I played it, then the voltmeter will show a 1 volt. And for another example, if we change the 1 volt to a 10 volt, and it will require a 9 kilo ohms for multiplier resistance, and if I stimulate it, the voltmeter will show 10 volts in the readings, and the reading of this will be verified using the calculation by Safwan. Thank you.
Assalamualaikum. My name is Saimon Safwan and I will be presenting the calculation part of this video. So in the previous section, Amir Faris presented the simulation of the circuit. So now I will show you the calculation. So by following Amir Faris, he gave us that the current in the movement is 1 milliampere, which is the same as the R multiplier, and also the total current, which is also 1 milliampere. He also said the applied voltage is 10 volts and the resistance of the movement is 500 ohms. So now with these values, we will find the voltage at the movement using this formula. E equals to IR. So given I equals to 1 milliampere and resistance 500 ohms, we get 0.5 volts in E movement. Now, since we have E movement and we have the total voltage, to get the E for R multiplier, we just have to minus the E total minus E movement. So we get 9.5 volts. Now, since we have the voltage for R multiplier and the current for R multiplier, we can also find the resistance of R multiplier. By using same equation, E equals to IR, we get R equals to 9.5k ohms. Since we already have the resistance for movement and R multiplier, we just add them up to get the total resistance of the circuit, which will be 10k. Okay, so that is for if the applied voltage is 10 volts, but for different ranges of voltages, for example, 1 volts, we just have to change the R multiplier into 500 ohms, which will get 0.5 volts for ER multiplier 2, so we get total of 1 volt. For 100 volts, we change the R multiplier into 99.5K, and for 1000 volts, we change the R multiplier into 999.5K ohms to get 1000 volts. That is all. Thank you.